Hey, I'm here. Can you let me in?
Yeah, sure, I'll let you in. Hey guys, Aaron here. In this video, I'm going to show you how to make a smart video doorbell / intercom unit out of a Raspberry Pi. The doorbell is equipped with a mini screen and camera so that you can chat with your guests over internet calls. I've created a simple script for this project that sends a notification to your phone when the caller presses the button, but it could also be used as an always-on intercom system for your office. Let's get started. Our 3D printed housing looks a little bit like this. This is actually our third revision of this housing. We've made a couple more and we couldn't get the bevel right, so we kind of had to keep iterating on it. I should mention that all the 3D printed files, a full parts list, and write-up will be available on hackster.io if you miss anything in the video. Underneath the top housing, we have this screen, which attaches to our Raspberry Pi. So this is where the video is going to show up on the doorbell. We also have a button, so you can press the button to activate the doorbell, and a speaker so that you can hear the person on the other end of the line. I started by taking 4 female hobby jumper wires and cutting the ends off one side of those wires. I stripped them, and these are going to be the wires that we use to connect the button to the Raspberry Pi. I tinned one end of those wires, and this is just to make the solder flow easier onto the button when we attach it. My button came with a resistor, so I attached that to the yellow wire. And now I'm just tinning up the ends of the button here so that the wires can connect a little bit easier. Again, my resistor was on my yellow wire, so I attached that to the wire in the diagram here, and my load in this case is going to be the Raspberry Pi. So just make sure to keep track of your wires for that. Speaker was easier because we had a connector, so we didn't have to solder anything. Our 3D printer was too small to print this in one piece, and this is the back section of the doorbell. We're going to have to glue these two parts together. And these didn't come out perfectly from our printer, so we're going to file them down before we glue them together. And the trick is actually to file both pieces back to back like this, so that when you glue them together, even if there's a slight slope from this side to the other side, they still fit together perfectly. This part doesn't have to be too precise, so I used my wood clamp to clamp the pieces together and filed those sides down. Next, I used some super glue, and I kind of held the pieces down with some other parts and super glued those edges together. You definitely want to use a lot of super glue on this part to make those sides strong. I'm using a small USB microphone for this project, and you want to make sure to plug it in that slot because there are a few holes over that slot on the enclosure that make it easier for the microphone to capture audio. Next, I screwed the Raspberry Pi into the enclosure using some M2.5mm screws. Now these holes don't come off the 3D printer threaded, so you need to either make sure that you push those screws in pretty hard to tap the holes, or use an actual tap to do that, which is probably the better choice. In order for the homeowner to chat with the visitor, we're going to use this mini camera which attaches to the Raspberry Pi. And we've actually used one of these before for the smart security camera, and we thought it worked pretty well, so we're going to use it again. Check this out. So when we designed this enclosure, we thought the camera goes here, plugs in here with this little strip here, but it turns out the camera actually plugs in here. So we're going to have to bend this a little bit more than we would like to actually get that plugged in, but we think it should work. Using some tiny 2mm screws and that technique I just described, I screwed the camera into the enclosure. We had to really put this wire in a weird position to get it into that slot, and you want to make sure it's really connected to the Raspberry Pi because this gave us issues later on when we tried to connect the camera and code. Next, I test fit the button, but the hole came out a little bit too small from the 3D printer, so I just took a file and opened that up a little bit. And it was a little scary getting that button in place because it sounded like this. But after it was in place, everything seemed fine. Next, I looked at the diagram for the button and cut the ends off the positive wires from the diagram on the button and then the red wire from the speaker and strip those. These are going to be soldered together so that we can connect them to one pin on the Raspberry Pi instead of multiple pins. It was a little tricky getting these in place, but I used my helping hands to solder all three of those wires together. Then I used the trimming from the red speaker wire to connect to the end of all three of those wires, and I wrapped it in some electrical tape so it doesn't short out. Next, I cut the ends off the black and white speaker wires. The white wire is the signal, the black is the ground. We're going to have to solder these directly to the monitor because there aren't any pins available on the Raspberry Pi. I would prefer to connect these directly to the Raspberry Pi, but it's what we had, so we chose to do it this way. You want to make sure to use a really fine tip on your soldering iron so that you don't burn the plastic on the audio output. But with a really steady hand, I was able to do it. And then I took my black wire and soldered it directly to the outermost pad and the white wire to the middle pad. I lined all the wires up so it was easier for me to see how everything would go together, and then I connected the pins to the Raspberry Pi, the power cable going to the 3.3 volt pin, the ground cable going to the ground pin, and then the load cable from the button going to an arbitrary GPIO pin, and I chose pin 26 for this. Here's a diagram so that you can do it yourself when you're building this project. It's difficult to get all the wires under the screen, and it might look a little messy, but once you get that screen on, it should be fine. Don't be afraid to kind of route the wires in different directions if they aren't fitting. And then I took the HDMI connector and connected that to the Raspberry Pi. Next, I took the speaker and using some 2.5mm screws, I screwed that speaker into place. I had to use the same technique that I did earlier where I used some force to kind of tap the holes with the screws. And then I fit the cover on the project. The cover is a little finicky to get to fit in place depending on how your 3D printer printed the parts. So I had to actually file down my parts a little bit. Then I took some 3mm screws and screwed in the back plate. I should also mention that for power, I took a right angle micro USB, connected that to the Raspberry Pi, and routed it through the back of the project. Looks a little ugly, so you could also power through some standard wires and the GPIO pins if you wanted. Okay, so now I'm on my computer, and I'm recording this after the fact, which is why I have this beard. Alright, so I'm connected to my Raspberry Pi through VNC on my computer. The first thing you're going to want to do is enable your camera. So I've opened up a terminal window here, and I'm going to type sudo rasbconfig. This opens up the configuration options for your Raspberry Pi. I'm going to go down to interfacing options and select camera. I'll hit yes to enable the camera and then OK. Once I finish, I will be asked to reboot, and I want to hit yes for this. Okay, so after you've rebooted, you can type sudo rasbstill, specify an -o option, and then your file name. In this case, I'm saying output to test.jpg. Now I'm just going to quickly open up this image, and you can do that through the document viewer, which is these two folder icon up in the corner here. And let me just double click to open that. It looks like my dog was actually looking at the camera when I took this photo. But you can see it's working. If you ran into any issues when running that command, there might be a problem with your camera, so you have to troubleshoot if that's actually connected to your Raspberry Pi. Okay, so the next step is enabling the microphone. To do that, I'm going to go to my terminal again and write ALSLA mixer -C and then L, which opens up this interface where you can configure sound input. If I press F4, it'll take me to the capture options for my microphone, and I'm just going to bump this all the way up to 100. This sets the input level on the microphone. Because by default it's pretty quiet, you want to up that so that you can hear the audio. Next, I'm going to run this command, and it's a pretty long command, but this command will be available in the GitHub repo and also on hackster.io, so you can copy and paste it if you want. Basically, it's going to capture some sound and save that sound in a test.wav file. So as you can see here, it's recording some input, and we'll just let this record for a little bit. Now I'll stop that. To play the sound back, you can type a play and then the name of your file, which is test.wav. So this will play back our sound and we can check that the microphone's actually working properly. Next, we actually have to store those settings so that when we reboot, it will persist that information. So I'm going to type sudo asla control store, and that will store our settings. Okay, so now the next step is going to be enabling video calls. So I'm going to go to a web browser here, and we're using a free open source internet call software called Jitsi Meet. So I'm going to connect to that, and I need to configure Jitsi so that when we open this up through the software, it will already have configurations for the microphone and the camera. So if I type in a meeting name here, this can be any meeting name. In the actual program, it uses a unique ID, but I'm just going to type Hacker Shack Doorbell for this example and hit go. It opens up a new call and it says that we need to use the camera. I've already configured this, so it works for me, but if you haven't had it configured, you need to go into settings here and make sure that you're actually connected with your camera. In some cases, this won't work because Chrome doesn't pick up that you have a camera, so you actually need to go in the Chrome settings. And so let me just show you how to do that. So if you go in the Chrome settings and you search for camera, it will show you all the sites that you've enabled the camera for. So I'm just going to go into site settings and click on camera here. And you can see Jitsi Meet is down here. I want to select this camera, and you might have to experiment with this a few times because there are a few different options in here. But this is the camera setting that worked for me. Then I'm going to go back to the microphone and select my USB device. There are a bunch of different options here, but this one worked for me. And once I've done that, I can exit out of the settings. Next, I'm going to download the script in order to make this run properly. And I've provided the script on our Hacker Shack GitHub account. So if you search for Hacker Shack GitHub, you should be able to find our organization. And I'll just click on the first link here. The repository is called Smart Doorbell. So you're going to want to click on that. And then click the clone or download button up here at the top. And download zip, which will download the code onto your computer. I'll extract this file and put it in my home directory. And now if I click into that folder that I just abstracted, I can see the doorbell.py file. I'm just going to copy that and paste it in the root of my home directory. And this is what we're going to be running when the program starts up. You can test it out by running python doorbell.py, and it should print out some commands and start up. Basically what the program does is waits for somebody to press the button and then plays a sound, opens up a web browser with that Jitsi Meet link, and sends an email to the email that you specify through these variables for somebody to click on and join the meeting. The meeting stays open for a set amount of time, closes, and then you can do whatever you want on top of that. So the program is pretty straightforward. It's just a simple script, only about 200 lines here. At the top, you have all the variables that you can change. I just want to make a quick note about security here. Since this doorbell is connected to the internet, and as a general rule of thumb, if anybody can access your USB on your device, they have access to all the information that's on that device, as well as the network that the device is configured to. So if you connect it to your private network, you probably don't want to put this outside as a video doorbell. I would just keep it inside and use it as an intercom unit. But if you connect to public Wi-Fi and maybe you have some sort of server that's sending the emails and creating the meeting links for you, it would be more safe to use this as a doorbell, but we didn't design it to be secure. So it's up to you to actually take action to make this device secure. That being said, you can easily extend the code to do whatever you want with it. This is kind of just a proof of concept to show you how to get the doorbell working. Okay, so if you look at the settings here, we have a bunch of different variables. I'll quickly go through them. The first one's just the pin that you connected your load wire to for your button. This is how long the screen stays active. We have a Jitsi ID that you can use if you want to hard code your Jitsi ID. But if this is not defined, then we just create a random ID for you. You can specify a sound effect if you want. Here's a setting for enabling the email. And you'll notice down here that I have the email and app password hard coded. If you're at all concerned about security, you don't want to put your app password in your app code because again, anybody could access it. You'd most likely want to create a server running up in the cloud with business logic concerned with sending emails and opening up video links. You would do validation at the server level. So even if some random actor makes a request to the service, you would still be okay because that sensitive information wouldn't be on the device. If you want to use a server for your project, you can use a service like Linode. I've been using Linode a lot recently, and it helps you take your DIY projects to the next level by providing personal Linux servers that help you run your projects in the cloud. If you're like us and you like to tinker, you should give Linode a try. With Linode's cloud storage, you could create an archive of your doorbell footage and access it from anywhere in the world. You could even create a media server and play music when your guest rings the doorbell. It's great for, providing more security services for your doorbell as well, like I mentioned earlier. All kinds of upgrades are possible when you build on Linode. Give Linode a try today. You can create a free account using the link in the description and get a $20 credit on your new account. We're going to do a few more things to make sure that the Raspberry Pi is set up for the video doorbell. First, we'll rotate the screen so that it aligns with the screen on the doorbell. To do that, I'm going to type sudo vim /boot/config.txt, and I'm going to add a new entry in this file, pressing I to enter insert mode, and I'll type display_rotate equals 1, press escape, and then capital ZZ to save. Then I'll type reboot to reboot the Raspberry Pi. And after reconnecting, you can see that the screen is now in portrait mode, which is great. I'm going to change this back to landscape just so we can finish out the video here. Next, I'm going to make sure this starts at boot. So I'm going to type make directory /home/pi.config/autostart. And again, all these instructions will be in the GitHub page and on Hackster. I'll type vim and create a new file in that directory called doorbell.desktop. In this file, I'm going to insert some more text here, and this will be to make sure that the program actually runs on start. And the exec parameter specifies where the script is. This will be the command that's run on start. I'm going to press escape and then ZZ again to save that. Now if I reboot, it should start up the program when the Raspberry Pi starts. I can test this out by pressing the button on the doorbell, which opens up a browser and displays a new meeting with a random ID, as you can see here. Okay, so to demo this project, we're going to mount it outside of our house, and we can't drill into the wall here. So we're just going to use some of this 3M exterior mounting tape and put it on the back of our doorbell, just like we've done with some of our other projects. And if you wanted to, you could also just use some screws here, mount some screws in the wall and then hang it on the screws. But we're just going to use the mounting tape on top of this plastic piece right here. Obviously, when it's mounted like this on the wall, somebody could just come up and take your doorbell. So you want to make sure that you trust your neighbors, which we do. But if you don't, just be careful and don't put it anywhere that somebody might steal it. You might have noticed that we also have an electrical panel on our home, and if we're making a more permanent installation of this unit, we would probably route this wire through that electrical panel just so it's not hanging down like this. But for the purposes of this demo, we're just going to keep it like this. Alright guys, thanks for watching this video. All the parts for this project and a full write-up will be available on hackster.io. So if this video was too long and you missed a part, make sure to check that link out so you can go at your own pace. If you haven't already, make sure to subscribe to keep up to date with all of our latest build videos. But until then, I'll see you next time.